Your homework assignment doing pages 10 and 11 in your homework packet over molarity and dilutions. I'm going to do the odd numbered problems. Remember that what we're doing is for practice so that you can do well on your quiz, and it's highly recommended that you kind of follow along with me and work some on your own so that you do okay on your quizzes. Make sure that you have your periodic table handy and make sure that you have your calculator handy. So I've got both of mine. There's one, there's the other. So let's get started. Number one. Oh, before I do that, I want to go ahead and write the formula for molarity at the top. Remember, molarity is moles over liters, and it has to be in liters. All right, the volume has to be in liters. If it's in milliliters, which we're gonna put it in milliliters and make you convert it, it has to be in liters. You just have to convert. So number one, what's the molarity of 250 milliliters of solution that contains 0.70 moles of sodium chloride? Well, let's see, what do I have? I need molarity, which I do not have, because that's my unknown. I have 250 milliliters, and I have 0.70 moles. Let's see, volume is, okay, so liters. This is not in liters. So the easiest way to convert this to liters is move your decimal point 3 places to the left. So my volume, which should actually be V, volume is 0.250 liters, and moles, 0.70 moles. And liters, oh, probably not a good idea. Okay, so the formula again, molarity is moles over liters. Plug my numbers in for the variables. 0.70 moles over 0.250 liters, and that's going to give me a molarity. 0.7 divided by, oh, it's not on, duh. 0.7 divided by 0.250 gives me a 2.8 molar solution. So 2.8. So let's check sig figs, shall we? That has 2 and that has 2. So my final answer can have 2. So my answer is 2.8 molar. All right, number 3. How many grams, looking for grams this time, of calcium chloride are in 250 milliliters of 2 molar calcium chloride solution? Okay, in this case, we're going to have to calculate moles in order to get that to grams. So let's see, molarity is 2.0. Moles, I don't have. Once I get to moles, I can convert that pretty easily to grams by multiplying by the molar mass of calcium chloride. And my volume is, I'm going to go ahead and convert it, 0.250 liters. See, 250 milliliters, 1, 2, 3 makes that 0.250 liters. I'm going to calculate the moles first. So if I'm going to use the formula, same formula as up here, if I want moles, I can plug these in and solve for moles, or I can rearrange the formula. Moles is going to be equals to molarity times volume, which is going to be in liters. Moles equals 2.0 times 0.250. Let's see what we get there. 2 times 0.250 is 0.5. So moles equals 0.5 moles CaCl2. Okay, I don't have to round to sig figs. Remember, you don't use sig figs until your final answer. So in order to get to my final answer, I have to now convert this half moles of calcium chloride into grams of calcium chloride. In order to calculate grams of calcium chloride, I'm going to have to multiply 0.5 moles times the molar mass of calcium chloride. So let's figure out up here what the molar mass of calcium chloride is. Calcium on your periodic table is 40.08. And there's 2 chlorines. 35.45 times 2 is 70.90. So I'm going to add these two together to get the molar mass of calcium chloride. 40.08 plus 70.9 gives me 110.98. So that is 110.98 grams per mole. I have half a mole. So grams is going to equal 0.5 moles CaCl2 times the molar mass, 110.98 grams per mole. So my final answer, let's see what I get, times 0.5, gives me that, 55.49. How many sig figs can I have in my final answer? Well, that has 2, and that has 2. So my final answer gets 2 sig figs. So let's look and see what we got. There's my 2 sig figs, 55. That 4 doesn't round that final number up. So my final answer is going to be 55 grams of calcium chloride. Okie doke. Let's move on to number 5. I'll write the formula up here right now. Let's see, molarity is equal to moles divided by liters. So what is the molarity? That's what I'm looking for. Of 1.5 liter solution that contains 0.5 moles of magnesium chloride. So molarity is my unknown. Moles is 0.5. Volume is 1.5 liters. If molarity is equal to moles per liter, I plug in my numbers for my variables. 0.5 divided by 1.5. 0.5 divided by 1.5 gives me 0.333333. And how many sig figs can I have? Yep, I can have 2. So my final answer is going to be 0.33 molar. There we go. All right, number 7. What's the molarity of a solution prepared by dissolving 80 grams of sodium hydroxide in enough water to make 1 liter solution? Well, I'm looking for molarity. That's my unknown. I have 80 grams of sodium hydroxide, and I know that I need 1 liter. I have volume, and I have grams. Well, that's not going to help me out because molarity is what I'm looking for. I need moles in order to do this. It's not going to work out unless I have moles. And I have my volume, which is 1 liter. So how would I get moles from this? Well, I would divide 80 grams of sodium hydroxide by the molar mass of sodium hydroxide. So I need to find out the molar mass of this sodium hydroxide. Sodium, 22.99 grams. Oxygen, 16 grams. And hydrogen, 1.008 grams. So we add all 3 of these together and see what we get. And I got that, 39.998 grams. Okay, so the molar mass of sodium hydroxide is 39.998 grams per mole. Oop, kind of off the page a little bit there. Sorry about that. Move that up a little. Yep, we got the whole thing now. So I need to divide this by the molar mass, and that's going to give me the number of moles. So 80 grams of sodium hydroxide divided by the molar mass, 39.998, and that's about 2. Right over that. So you can actually just do 2 if you want to. So that's 2 moles. I'm going to put that over here. And I'm going to plug these numbers into my formula for molarity. 2 moles, 1 liter. This is a 2 mole. So far, so good, huh? Okay, number 9. I'm going to write the formula up here again. Molarity, moles, liters. How many liters of a 0.5 molar potassium hydroxide solution can be prepared using 120 grams of potassium hydroxide? So now that I have grams, I need moles in order to do this whole formula. So let's write down what we've got. Molarity is 0.50 molar. Moles I can get from the mass, and then volume is my unknown. So I'm going to have to figure out the how many moles 120 grams of potassium hydroxide is. In order to do that, I have to find the molar mass of potassium hydroxide. Molar mass of potassium, there's only one potassium, 39.10. Okay, let me label them for you. O is 16, H is 1.008. Since there's only one of each in the formula, I add each of these together. And I get that number right there, 56.108. So that is the molar mass.